basically a AI won the Colorado State Fair, and it won the digital art section, and so a lot of people have been talking about this, and I just wanted to go through what the best, an experiment with the best that I found, open source equivalent to that, because that was a COTS product, commercial off the shelf. So because I'm using AMD locally, you can actually fix it even in Windows so that AMD runs for Stable Diffusion, but it was quite a pain in the ass, so I just switched over to Colab, which I assume is using NVIDIA in the background, which allows you to run. So the first step you're going to need to do is you're going to have the paid for version because you need enough RAM. Then you need to switch the runtime to high RAM, and I didn't write this. I found this on the internet. It was a, let's see, they don't, I'll look for the blog post and link it. So the first thing you do is you're going to pull in Miniconda, which is essentially an installer for Python. And the bang is an escape, and wget is a command that basically goes to a web address and pulls something in. So you pulled that in, you allow it to execute. This is basically change permissions, and X is add execute. And you execute it using, it's a bash script, so this is bash, and then / just says do it here on this script, and the location you're going to install everything into. From there, here's another escape. You turn on Conda, then you come in here, you git clone the repo. So basically this is just pulling in the code from, this is a code sharing. It's kind of like Google Drive or Microsoft, I think SharePoint, I've never used it, but it allows you to share code. Then you install the required libraries for Conda, or not for Conda, you've already done that. You install the required libraries for this Git repo. Now what we're doing here is we're pulling in the weights. So in machine learning, what happens is you create a set of weights. So you have an input layer, a series of hidden layers, and an output layer. So if it's an image, like you want to, for like image classification, let's say, the input will be each pixel at each, because each pixel in a computer is red, green, blue, and then so it's, if you have 50 pixels, you'll have 150 inputs, and it'll from those inputs, it'll have, usually they use fully connected when you're first starting. They're called convolutional neural networks, and each layer will connect to every other layer behind it with a weight on that set. And interestingly enough, fully random weights is usually the best way to do it when you're starting. And so then it runs through, and at the end, let's say you're trying to classify these images, is it a cat or a dog? If it gets it correct, it strengthens the pathways, so it reduces the resistance of the pathway between the neurons and the layers, and that's by that weight. So it's called a sigmoid, or a step function, that they use as the how much we want to weigh each level, and then they combine these out to create a space. And so from there, what you're going to do is you're going to keep improving your predictions over and over again until you're regularly able to predict between a cat and a dog. And you do have to worry about something called overfitting, which is where you've put in so many neurons in the hidden layers that you can memorize essentially every piece of your data. So you actually haven't learned anything, you've just memorized each and every image, which is similar to how people learn. So from here, we have installed this. So this is the important start. This is the Stable Diffusion script. So in here, Stable Diffusions, this is under, I think, config or something. There's something with a C. You're going to have your source, or that is if you wanted to edit the code. We're looking in, you can just read this, scripts. Okay, scripts, and then you're going to have your text to image script. And here it is. So this is just running. This will allow you to run the code. And here it's creating our image based off this prompt. So I guess I should explain that. So these are like different input commands, these dashes. So this is the number of images you want to create. This is the output directory. And this seed is just so you can recreate the same image over and over again. If you don't set this, usually they take it from the timestamp of your computer, like the last couple millisecond numbers. And this is essentially like trying to get the right number of iterations. And this is your prompt. So what it's going to try to build is a bright, beautiful solar punk landscape. This is the default that comes with it. And here's the image that pops out from that. So that's pretty cool. Now, let's try some other things. Let's say, we're creating a cat rides a dinosaur. Okay, so it's finished our first image, and we're going to display it. All right, there you go. What a beaut. So, that is not a cat at all. A cat rides a dinosaur. Huh. Well, it's a dinosaur, that's for sure. In a park, I guess. Well, let's try something else. So let's say, I noticed a lot of their prompts were about space, which, okay. And this time we'll make a couple more samples so we can show that, because when you're really doing this, you want to have a series of images you can pick from, and then you pick the best one. So that's how you kind of like improve it, and then you also work with the prompt to get exactly what you want it to say, and that's going to get you much better results. All right, so let's say our prompt is like a moose in space painting. And this is going to take a little longer, so I think on average they're taking, what, 39 seconds. So I would imagine this would take, 39 times 5 seconds. One thing to note here is that this is the current latest as of 9-2-2022 set of weights, so you're going to get the best, well, theoretically you'd get the best results with these. Sometimes you think you've improved and you've actually gone backwards, but so we'll see what kind of results, the 5 images we're going to get for this, and see how it looks. Just kidding. It can't allocate enough memory to make 5. I think I've done 3 in one of my tests, so let me try that. Oh, I think n samples is parallelized, so we'll see if it can handle this. But so I think in n samples, you're creating 3 at the same time, and in n iterations, you're creating them 1 at a time. I'm not certain that's true, but I believe that is true. So we'll look at that in a second. And so yeah, all of this is pretty interesting stuff. I accidentally muted myself, so this is later. So here's our moose in space. The first one, it's looking pretty good. Here's the second one. It's kind of horrifying. And here's the third one, which is kind of haunting. Very cool. None of these are painting, which is what I was thinking, but they're painting styles. Okay, so this is their GitHub repo, and this is where you could dig a little deeper. This is where I got the code from, and here are their images. So enjoy that. And then next we're going to go to the blog where I got the Colab code from. Here you go. So it's written by Ryan O'Connor, and it's called How to Run Stable Diffusion Locally to Generate Images on the website Assembly AI. And the Colab link specifically is that purple button. So have fun, and good luck.